Hello viewers, my name is Jeff Durkin.
And I'm Virginia Dutch.
And we're GNN, the Gas News Network.
Today in Gas News, we have breaking news.
But first we need to explain exactly what a gas is for all you who do not watch our program. A gas is an air-like fluid substance that is one of the three primary states of matter.
Gas is made up of small particles, but we'll get to that later.
And now to Andre Smith, who will give us the breakdown on gas.
Thanks, Jeff. We are outside GNN headquarters. We're outside testing the relation between force and pressure with the amount of balloon that we have filled with CO2 and oxygen. Well, as you can see, force pressure are very related because as the volume decreases, the pressure increases and it's compressed.
So are you saying that pressure and force are directly related?
Yes, it is, Virginia Dutch.
Thanks, Andreas. Now with the topic that will affect the general public.
Congress passed the ideal gas law this morning, which explains the mathematical relationship between pressure, volume, temperature, and the amount of molecules in a gas.
We'll discuss this more as the story develops, but now here's Stan Trong with the 5 assumptions of the kinetic molecular theory.
Yay! Thanks, Jeff. Now, one of the first of the 5 assumptions is that gas contains very small particles that are relatively far apart. Collisions between the particles are also elastic, meaning they do not lose energy on impact. These particles are so small that also in constant motion, at this they are random.
So a gas will never run out of energy.
Precisely, which leads to my next point, that particles have no force of attraction between them. The temperature of the gas relies on the kinetic energy of the particles.
So now let's talk about particles.
The particles are always at high speeds.
They're not regulated and are at random motion, which we stated earlier, but just in case you were not paying attention.
Now here's Pedro Gonzalez.
Thank you, Virginia. Gases are everywhere. Gases are in our atmosphere all around us, but invisible to the human naked eye. Well, I have this can of soda right here, and when they make the soda, there's CO2 carbonated within inside the liquids we have here, which we call Coca-Cola. And when I shake it, it increases the amount of volume and pressure in there. So when I go to open the soda, it should erupt because of the CO2 and all the stuff come out through fizz for a nice cold beverage.
Okay, so now that we know the basics of gases, we can apply that to the real world that you viewers see every day.
Imagine a patio with a grill and a reporter, Phil McCracken.
If there is a grill that is cooking, there is a change on a molecular level. When heat is applied to oxygen in the air, oxygen gas is chemically changed into either CO or CO2.
So now we can move on to some laws.
Boyle's law states that the temperature remains the same, the pressure and volume are inversely proportional.
Now here's our reporter Nelson with the breakdown on Boyle's law.
Hello, I am standing on the scene with the common household object, lemon refreshener. Now, how this spray can works is all about the pressure inside of it. The extremely high pressure within this can causes the gas particles to become liquefied, thus reducing volume. When the pressure is released, the liquid propellant is shot out of the can. Lemony fresh.
Next up, we have Gay-Lussac's law.
Gay-Lussac's law states that the volume is kept at a constant. The pressure and temperature will change when the other is changed. Next up, we're going to talk about a fellow named Charles.
Charles' law states that a gas at a given constant pressure has a volume and temperature that is directly related.
Finally, we have the combined law, which is the essential wombo combo of all gas laws.
This law incorporates all 3 of the gas laws that we just discussed in order to find a constant of a gas.
This is used in many industries and sciences as a way of securing a constant. So that's it for today's broadcast. Catch us tomorrow and we'll talk about everything else there is about gases. Today we've gone over volume, temperature, pressure, and also a few laws that have been passed today. We'll hope to catch you tomorrow on GNN.
Signing off.
Both of us.
Same time.
Yeah.
Bye.